So we're going to look at section 1.6 here, continuity of trig functions. We have a theorem that says if c is any number in the natural domain of the stated trig function, then the limit as x approaches c is sine of x is sine of c. And actually all of these it's saying, all you do is take this number that you're approaching and plug it in right there into your value for x. Now, what do they mean by the natural domain? It means basically be careful here. Like let's take, for example, this one right here, okay? If c is any number in the natural domain, then that works. Well, think about your tangent function, okay? Whenever you drew this in trig, what did you have? You had negative pi over 2 were some vertical asymptotes, right? And what happened with your tangent function? It did something like this, and it had what, several cycles and so forth, right? Just make sure that the c values in the natural domain when you do this. For example, if c were pi over 2, that would not be in the domain of this tangent function. All right, but otherwise, what do? You just take that number, substitute it in for dx. All right, page 2. We have an example here. It says find the limit as x approaches pi over 2 of the cosine of x. How about the cosine of x? Okay. What does that look like? Doesn't that look something like this if we graph it out? Goes on forever in both directions. So if x is approaching pi over 2 here, pi over 2 is in that natural domain of the cosine function. So I could just say, okay, this will be equal to the cosine evaluated at pi over 2. Now what's the cosine evaluated at pi over 2? Most people think of the unit circle, okay? They think if we rotate through an angle of pi over 2, where are we at on the unit circle? Think about the unit circle. Ain't much of a circle, but we get the point anyway. That's the point what? The 0, 1. Remember these run cosine of theta, sine of theta. So what's my cosine value? It's 0 at pi over 2. So I can say that's equal to 0. Now, if you did not memorize the unit circle for some reason in trig, make sure you memorize it for this course. You're going to see it over and over and over again in this course, okay? So you're going to see it if you take Calc 2 over and over again as well. So make sure you get that unit circle down. All right, part B. The limit as x approaches 5 of a trig function. Now notice x is approaching a number. So if this number is in the natural domain of the sine function, I could just substitute it in. Well, the sine function has all real numbers as its domain. So that means then I could just substitute in this 5 for x. So I have the sine of pi over 2 times 5. Say that's a sine of 5 pi over 2. Let me see what the sine of 5 pi over 2 is. Let me use the unit circle again, okay? Let me rotate through an angle of 5 pi over 2. Well, it might be easier if I take that 5 pi over 2 and convert that to a mixed number. Isn't that 2.5 5/2 times pi, right? So what does that mean? That means I'm going to rotate through an angle of 2.5 pi. So if I rotate here, that's 1 pi, that's 2 pi, and that's another half pi, right? Okay, so think about that. If I'm at that spot on the unit circle, so on the unit circle, if I'm at this spot right here, what is that order pair again? It's 0, 1. How do we say these order pairs run? Cosine, sine. So what is my sine value right there? It is 1. Got to know that unit circle. Our next example, find the discontinuities if any f of x is equal to the sine of x over x minus pi. Actually, we did some of this in the last section, didn't we? We said, okay, if we look at this function, we can look at it like we have an inside function right here, which is x over x minus pi. And then we have an outside function right here, which is the sine of something, right? So we need to consider the inside function first, discontinuities, and then the outside function. All right, let's do so. All right, for the inside. What do I know about the inside? Well, if I have this right here, what do I know about it? I know the bottom cannot be equal to 0, right? So I'm going to have a discontinuity where the denominator is equal to 0. So that's going to be where x is equal to pi. I'm going to have discontinuity. Now, how about the outside, the sine? Will the sine function be discontinuous anywhere? No, it's continuous on all real numbers, right? I mean, even think of the graph. What does that look like? Looks like this, right? Looks like this, and it keeps on going forever in both directions. It never has any jumps, breaks, or skips. Like it doesn't do this, and then have an open circle, and that, and so forth. It doesn't do something like this, where it jumps from there to there, okay? So the outside is continuous everywhere. The only place I'm going to have a discontinuity is where the inside is discontinuous, which is at pi. How about part B? Part B. Maybe I'll go to another page for this one. Part B is going to look something like f of x is equal to the sine of x squared minus 2. The inside function is x squared minus 2. Outside function is sine. The inside function is a polynomial, right? So it's continuous at all real numbers. Outside function is a sine. It's also continuous at all real numbers. So if the inside and outside are both continuous at all real numbers, where are my discontinuities? We don't have any here. So we could put none, or we could put NA, or you could put continuous everywhere. I think Wiley has NA, so that's why I'm using NA here. How about C? F of x is equal to the cosecant of x. Okay, this time I don't have so much of an inside and outside. I guess you could look at it as x is the inside, but it doesn't really matter. All right, most people are much more comfortable doing this, saying, okay, well, I'm going to use my trig identities and say this is 1 over the sine of x. Now, where would this function, 1 over the sine of x, be discontinuous? It's going to be discontinuous where this denominator is equal to 0. So it's going to be where the sine of x is equal to 0. Now, where's my sine of x equal to 0? I don't know. Maybe let me picture the unit circle here, okay? Here is pi over 2. Here is pi. Here's 3 pi over 2. Here is 2 pi. I think about my unit circle. Looks something like this, right? What is this point on my unit circle? That's the point 1, 0. This is the point 0, 1. This is the point -1, 0. And this is the point 0, -1. Now remember how you order pairs, right? Remember cosine of theta, comma, sine of theta on the unit circle, right? All right, so what am I looking for? I'm looking for where the sine is 0. So if the sine is my second number in order pair, where is that 0? That would be 0 here. Actually, let me pick another color. That'll be 0 here. That'll be 0 there, right? So where does that happen? That happens at an angle of 0, and it happens at an angle of pi, happens at an angle of 2 pi. But if I keep going around, like if I go around again, then I'm at 3 pi. Keep going around, I'm at 4 pi, 5 pi, 6 pi, and so forth, right? What if I go around backwards? What if I go to negative pi? That I have a sign of 0 there. What if I go around negative 2 pi? I'm back at a sign of 0. Negative 3 pi, I'm back at a sign of 0. Y'all get the picture. So how am I going to write this? One way I could write this is I could say I have discontinuities where x is equal to, let's see, we could say something like n pi, where n is an integer. Because remember, n runs through the integers. So you could have 1 for n, 1 pi, then you could have 2, then you could have 3, but the integers also cover the negative numbers, negative 1, negative 2, negative 3, and it also covers 0. Or could you have wrote it, could you have written it this way? 0 plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, dot, dot, dot. Yeah, you would have had to make sure you put the dot, dot, dot right there, okay? To show that it keeps going. Same thing with the first answer. Make sure you put where n is an integer, not n is a number, because n can't be a fraction or a decimal. N has to be strictly, basically a whole number, an integer. Let's look at, what was that, part C? Yeah, so let's look at part D. D is in dog. Let's see, we have f of x is equal to 1 over 1 minus 2 sine of x. Let's find the discontinuities of any here. Well, I see right away, I do not want this denominator right here to be equal to 0. Okay? So I'm going to have a discontinuity where 1 minus 2 sine of x is equal to 0. Well, let's solve for x. So we subtract 1 for both sides. We have negative 2 sine of x is equal to negative 1. Divide by negative 2. Sine of x is equal to 1/2, right? So now what do I want? I want to know the x values. I want to know the angles. Where when I take the sine of them, I get 1/2. Hey, it's unit circle time again. Here is my unit circle. Did you just throw up a little bit? Because you're so sick of seeing the unit circle. Well, what? You're going to throw up a lot more later on then, because we're going to see it a lot more. All right, so how do these ordered pairs run again? Cosine of the angle, sine of the angle, right? What do I want to know? I want to know where do I have a sine that is 1/2? Where do I have a sine that is 1/2? All right, let's see. So if I think about, let me pick a different color here. So if I think about an angle like right here at pi over 6, where am I at on the unit circle? I'm at square root of 3 over 2, 1/2, right? So my sine is 1/2 where? At pi over 6, right? So I can say x is equal to pi over 6. All right, let's see what else. How about if I go with quadrant number 2, and I look at pick a different color here, and I look at a reference angle that's displaced here, pi over 6 units. What point am I at right here? I'm going to have, remember on the unit circle, I have the same numbers values as this, but the x is going to be the opposite. Negative square root of 3 over 2, 1/2. So my sign's the second number in order pair. Second number in my order pair is 1/2 here. I want to know, where is the sine of x equal to 1/2? Well, where does that occur? It occurs at that reference angle, but what's the actual angle right here? What would that angle be? Remember, it would be what? I'll pick a different color. Remember, it'd be something like pi, and then do away with this much, right? Or pi, or I could say pi, subtract this amount, right? No. Hold on, drew that wrong. Sorry, it'd be pi, and then back off that amount. Or I could say pi, subtract that amount, right? Okay, let's write that up. Other will be pi, subtract that reference angle up, pi over 6. Now what does that give me if I did a subtraction? That's 6 pi over 6 minus pi over 6 is what? 5 pi over 6, right? How about a reference angle of pi over 6? Let me draw another circle here, okay? Getting a little messy in here. What about if I look at the reference angle right here of pi over 6? Or the reference angle here of pi over 6? Will that give it to me what I want? Let's see. What order pair would be right here? It'd be the same values as these, but maybe the signs would be a little different, okay? In fact, it'd be square root of 3 over 2, negative 1/2 here. And this one, similarly, it'll be square root of 3 over 2 and 1/2, but each one of these numbers would be negative in there. So does that work? Remember what I'm looking for. I'm looking for the sine of x is equal to positive 1/2. Well, the sine is the second number, right? It's a negative 1/2 there and a negative 1/2 there. So this does not work. But what else works here? Well, let's see. Y'all told me an angle of pi over 6 right here works. What about whenever I go around completely? 2 pi to pi over 6. What if I go around completely again? Another 2 pi and so forth. I'm back at a sign that is 1/2, right? So what do I need to put on each one of these? I need to put plus 2 pi n plus 2 pi n, where n is an integer. Where n is an integer. Because I'll get what happens whenever I go around again. Like if I start right here, go all the way around 2 pi again, I'm back right here, back at a sign that is 1/2. There's my discontinuities. What was that, D? So here will be E. How about f of x is equal to 1 over 1 minus 7 sine of x? How do I do this? I'm going to do it like I did the last one. I say I'm going to have a discontinuity where my denominator is equal to 0. It says negative 7 sine of x is equal to negative 1. So sine of x is equal to 1/7, right? Now let's think about the unit circle again. Here's my unit circle right here. Now, where's the sine of x equal to 1/7? 1/7 was not in an order pair I had to memorize whenever I memorize the unit circle. But I could get some kind of picture where it's at. It would be in this quadrant right here. It'll be in that quadrant right there. Then what angle would this be right here? Well, remember, technically, to solve this right here, what do? We say x is the angle whose sine is 1/7, or the inverse or arc sine of 1/7. Think about how that reads. X is the angle whose sine is 1/7. Same thing here. We're looking for x. The angle that whenever I take the sine is 1/7. Now, if I try to simplify this, I do not get an exact answer. I get some decimal in my calculator. So what I'm going to do is I'm going to write this up as this reference angle right here. I'm going to say this is the inverse sine of 1/7, this angle right here. So one of my answers is going to be the inverse sine of 1/7. What about in quadrant 2? We talked about the sine in quadrant 2. So also right here we have a reference angle of the inverse sine of 1/7, right? So what is this angle from here to right here, okay? What is that angle? Remember how you find that? You say, okay, if I go this much, that's pi radians, but then I want to back off this reference angle or subtract off that reference angle, which was that. So what is that going to be? That's going to be an answer of x is equal to pi minus that reference angle, inverse sine of 1/7. But remember, every time I go around 2 pi more, I get to another discontinuity. So each one of these I need to add plus 2 pi n plus 2 pi n, and make sure you put where n is an integer. There's my discontinuities.